start creating our own classes. So before we do that, I'm going to review some fundamental terms so that, we're all on the same page. And then after that, I'll show you how to make a class in Java. OK, so we'll start with what's a type. So a type is a set of values and the operations that you can perform on those values. Right? So int, what are the set of values? Well, they're the set of 32-bit signed integer values. Right? There's a minimum value and a maximum value. What operations can you perform with those values? Well, you can do all of these. Right? So you can do arithmetic, you can do comparisons, and there's a few other things you can do. Right? So an int is an example of a type. Right? A string is another example of a type. Right? So a string is a sequence of 0 or more characters. Right? What can you do with a string? Well, a string's got a whole bunch of methods. Right? So those are the things that you can do with a string. String also has the plus operator defined for it. You can do assignment, you can do comparison, et cetera, et cetera, et cetera. Right? So again, a string is a type. Right? It has a set of values and it has some operations that you can perform on them. Finally, a list. A list is another example of a type. Right? A list is a sequence of 0 or more elements of the same type in Java. Strictly speaking, that's compatible type, but we'll talk about that later. Right? What can you do with a list? Well, it's got a bunch of methods. Right? OK, you know that there are primitive types. So int is a primitive type. Right? And you know that there are reference types. Right? So if it's not a primitive type in Java, it's a reference type. Right? Arrays are reference types. String, list, array list, and so on and so forth, those are all reference types. Right? And there's a difference between a reference type and a primitive type. And I'll actually tell you precisely what that difference is in a few slides. OK, so what's a class? Well, a class is just an implementation of a reference type. Right? So for example, classes let you make your own types. Right? That's essentially what they are. So they're user-defined types. Right? String is a class. Someone wrote the string class. You can actually go and look at the source code for it to see how they did it. Right? So someone, the authors of the Java language, I guess the authors of the standard library, created this string class to define the type of, to define a type that represents a sequence of characters. Right? Similarly, the designers of the standard library created an array list class. Right? Again, you can go look at the implementation of this. Right? Just Google array list source code. Right? And you can find the implementation of array list. Right? This thing called list that you might have seen on your assignment and that you might have seen in some of the notes, the thing called list is actually not a class. It's something else. But we'll talk about exactly what that something else is later on. Right? It's not a class, but it's still a reference type. OK, so what's an object? An object is just an instance of a class. Right? So you use a class to make variables. Right? Those variables are just objects. Right? So your class is the blueprint that's used to make objects. Right? So for example, when I write new array list, right, that uses the array list class to make an array list object. Right? A reference to that object is stored in the variable t in this case. Right? So what's a reference? Now they should have told you what this is in 121, but that doesn't always happen. So a reference is an identifier that can be used to find a particular object in memory. Right? So in many Java implementations, references are memory addresses. So you can think of a reference as just a unique identifier for every object that's in your program. Right? So in Java, a variable whose type is not a primitive type stores a reference. Right? So for example, I've got an array list object on the right-hand side. I guess strictly speaking, I have a reference to an array list object on the right-hand side. That variable t stores a reference to that object. Right? So in this course, we're going to think of references as being memory addresses of an object. Right? So when you make an object, it has to live somewhere in memory. Right? The Java virtual machine needs to know where is that object. So it needs to be able to find that object in memory in order to use it. Right? So in order to call any methods on that object, it needs to know where is that object in memory. Right? The where is that object in memory, that's called a reference. Right? And so we're just going to say references are memory addresses. That doesn't have to be the way it's implemented. That's how we're going to think about it. OK? OK, so to make this a little more clear, we can actually visualize objects, references, primitive types. right? We're going to use this thing called a memory diagram. So this memory diagram, it's not complicated. It's just got 3 columns, right? So it's just a table with 3 columns. Column 1, you have a variable name, right? If you want to, you can have a 4th column, which has the variable type, right? I'm just going to use 3, right? So we have a variable name. The next column, we have the memory address. Now, I'm just going to think of memory as being a giant array, right? So your address is just an array index, right? So 0, 1, 2, 3, 4, 5, up to however much memory you have, right? So the addresses are unique, right? So every row has its own address. And then in the right-hand column, it's the value that you store in that memory address, okay? So it's the value that you store in that memory address. Now, the value that we can store in this particular model is one thing, right? And actually, it's going to be one number. That's all that we can store in this column, right? One number or one true-false value. And you might think that's weird, but you'll see how this all works in a second, right? So here's an example of a little program up here, right? So I've got a double variable called x, right? I assign the value -1 to it, right? So if you were to sketch what that looks like in memory, right, somewhere in your computer memory is a variable called x, right? Its value is the value -1, all right? Now, T is a new array list, right? So T is a reference to a new array list object, right? So when you write new array list, right, what happens is new allocates memory for an array list object, right? Where does it allocate it? Well, it allocates it somewhere. You don't know where, and you can't control where in Java, right? So here, I've drawn it at address 700, right? So an array list object appears somewhere in memory. We don't actually know what's inside that object, right? So after this line, there's a bunch of stuff here. So there's stuff that belongs to the array list object. We don't know what that is unless you look at the source code. We don't care for the purposes of this slide, right? All that we care about is that there is an array list object at address 700, right? Now, T is a variable. So T appears in memory as well, right? You can put it wherever you want. I'm going to put it at address 101, right? Now, what does T store? T stores a reference to the list, right? For our purposes, a reference is just a memory address. So T stores the memory address of that object, right? So I used the little letter A after the number 700 to indicate that this is an address, right? So 700A, memory address 700, right? Go to memory address 700, and you see there's an array list object here, right? Now, when you write U equals T in Java or Python, they both do the same thing, right? If T is a reference type, right, then when you write U equals T, you mean take that value and copy it into U, right? So take the value, copy it into U, right? So notice what does not happen in this example, right? You do not get a second list, right? T and U both refer to the exact same list, right? So if you use T to change the list object, right, and then you use U to look at the list object, U and T both point to the same list, so they both see the same changed list, right? So U and T, they both refer to the same list object, right? You don't have 2 lists, you have 1, right? U and T both happen to be names for the list, for that list, right? Now you've got 2 different names for the same list. So we say that U and T are aliases, right? Different names, same object. Okay, so for reference types, what does the variable store? It stores a memory address. For primitive types, what does the variable store? It stores the actual value of the primitive type, right? So x is primitive, so it actually stores the value -1, right? If you had a Boolean variable b whose value was true, then the value here would be true or false, depending on the value of b. Right? If you have a reference type, right, then what you have is a memory address that's stored, right? The actual object lives somewhere else in memory, right? But it's not stored right there, right? So T is not the object itself, right? T is a reference to the object, right? U is not the object itself. U is a reference to the object, right? There is no way in Java for you to actually get the object, right? So there's no way for the programmer to find out where is this object actually in memory, right? You always have to go through a reference in Java. The same is true in Python. All right. Any questions so far? All right, so keep all that in mind. I'm now going to describe to you something called the object model. So this is not specific to Java. This applies to all object-oriented programming languages. Okay, so in procedural programming, the stuff you did in 121 and 101, right? Or I guess whatever precursor you took to 121. So procedural programming focuses on decomposing a program into functions, right? You pass data to the functions operate on the data, they might return some information back. Right? Object-oriented programming focuses on decomposing programs into objects. Right? The objects contain the data, right? And the objects operate on their own data. So that's the big difference between the two, right? So the way your program is structured is fundamentally different, right? Procedural programming split everything up into functions and maybe modules in Python, right? Object-oriented programming split everything up into objects, right? All the data lives in the objects. Okay, so there are 4 main elements to what's called the object model, right? So these 4 terms here, right? So let's look at the terms one at a time. So there's something called abstraction, right? So this is fundamental to all object-oriented programming languages. So abstraction is one of the fundamental ways that we humans cope with complexity. Right? So an abstraction denotes the essential characteristics of an object that distinguish it from all other kinds of objects, right? And thus provide crisply defined conceptual boundaries relative to the perspective of the viewer. Okay, so what does that mean? Well, let's think about the string class, right? So the string class is an abstraction of a sequence of characters, right? All of your string operations live inside that string class, right? So there's your, right, so they all live inside the string class, right? A string is different than a list, right? In Python, that's not quite so true, right? Python treats all sequences the same way, right? But Java doesn't. So a list is different than a string, right? So the list lives inside of its own class, and the list provides its own abstraction, right? Notice this relative to the perspective of the viewer, right? So the viewer is the user, right? What they are, do I explain this a second? No, okay. So what does this line here mean? So it means something like the following. So imagine you wanted to create a class called car that represents a car, right? A vehicle, right? Now, exactly what would you put into that class, right? So what data would you put into it? What methods would the car class have, right? So the answer is it depends, right? It depends on why are you making this car class, right? Are you making this car class because you want to sell used cars, right? If so, the data that you put into it would be specific to how you would sell the car, right? So cost, make, model, stuff like that, right? If you were making a car because you were trying to implement a video game, then it's very different, right? You'd want to know how fast can the car go, how fast does it accelerate, and things like that. What does it look like, right? And stuff like that. So that's what the relative to the perspective of the viewer means, right? What you mean by a car is different depending on why you're creating this class. Okay, so what's encapsulation? So this is term number 2. Right? So encapsulation, that's the process of compartmentalizing the elements of an abstraction that constitute its structure and behavior. So encapsulation serves to separate the contractual interface of an abstraction and its implementation. So what they're saying here is, right, in encapsulation, right, you take an idea, so your abstraction, right, and you plunk it in an object-oriented programming language, you plunk it into a class. Right? That class has methods, right? So the methods of your class, that becomes your interface to how you use the object, right? So that determines how you use the object, right? What methods can I call using this object, right? All of the data, right? So all the information that you need for your class goes inside of the class, right? Okay, what about modularity? So modularity is also related to encapsulation. So modularity, the act of partitioning a program into individual components, can reduce its complexity to some degree. Right? Modularity creates a number of well-defined documented boundaries within the program. Right? So when you create a class in an object-oriented programming language, that's an example of modularity. Right? I take the idea of a string, I plunk it into its own class. Right? I take the idea of a list, I plunk it into its own class, et cetera, et cetera, et cetera. There's nothing from stopping you from trying to mash a string and a list into one giant thing and plunking that into a class. Right? But then it becomes very hard to implement, debug, maintain, et cetera, et cetera, et cetera. Right? So it's possible to take a Java program, some huge Java program. So imagine like PowerPoint or something like that, or Microsoft Word. Right? Technically, it's possible to plunk all of that functionality into one class. Right? Trying to debug and implement that class becomes a nightmare. Right? So the idea in modularity is you break your program up into small pieces. Right? So partition the program into individual components. Right? Then you can implement the separate pieces. Right? If the pieces are small enough, it's relatively easy to now implement, debug, and maintain. Right? Rather than putting everything into one giant program. Right? It turns out Java has three different, at least three different mechanisms for modularity. Right? And so we'll look at those a little bit later. Okay, hierarchy. We're going to look at that in a few weeks. Right? So for now, we just need to be familiar with the first three terms. Okay, so how do we organize a Java program? So you've already seen how a Java program is organized in assignment 2. Right? Assignment 1, you just wrote one class. Right? Assignment 2, you actually wrote one class, and then you have some other classes that work with it. Right? I guess that's not true. In assignment 1, you had a separate class as well. But anyway, this is what a typical Java program looks like. Right? So each gray box, oops, there you go. Each gray box, that's one source code file. Right? So one .java file. Right? Inside each file, right? Typically, it starts with 0 or one package name. Right? So in all of our assignments, they always have their own package. Right? Package A1, package A2. Right? You then have 0 or more import statements. Right? So if your class needs the functionality of a class that's in a different package, you import that class. You import those other classes into your class, right? So that you can use those other classes. And then there's typically only one class inside of a single source code file, right? So each Java file typically has one class. That's not necessarily the case, but that's often the case, right? There's one class per file. Okay, so that class right there is called a top-level class. Right? So it's a class that's not defined inside of another class. Inside a class, this you haven't quite seen yet, right? You've got some what are called fields or class variables. So you're allowed to place variables inside of a class, right? Those variables become the data that each object carries around with it. Right? So we'll look at an example of that shortly. You then have these things called constructors, right? So 0 or more of these, and then you have 0 or more methods, right? And so each file typically has that structure, and typically you have many of these files in a program, right? So for any non-trivial program, you're going to have several separate classes, right? For a large program, you might have thousands, tens of thousands. I don't know if you'd have 100,000, but you'd have tens of thousands of classes would not be unusual. Right, in a very large program. All right, so here is an example. You probably can't read this if you're at the back, right? This is an example of a class. Don't worry about it if you can't see, if you can't read it at the back, right? At the top, you've got your package, right? Next, you've got your import statements, right? Next, you've got your class. Now, inside the class, right, you've got some variables. These are called fields in Java. Then you've got 0 or more constructors, right? And then you have 0 or more methods, right? So the picture, don't worry about the code that's in the picture, right? Just look at the structure of the picture, right? One big box, that's your source code file, right? The next big box, so that bottom blue box, that's your class definition. Right? Inside your class definition, you've got fields, constructors, methods. Okay? And it's actually a lot more complicated than this if you were to go on to program in Java beyond what we cover in this course. Right? So you can actually have a bunch of other stuff in your source code files. Right? You can have these things called static initialization blocks, non-static initialization blocks, blah, 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 blah. Right? You can have classes inside of classes. Right? So you can nest a class inside of another class. We'll actually see examples of that towards the end of the course. You can actually put a class inside of a method. We're not going to see any examples of that, I don't think, but it is doable. You can have unnamed classes, which is odd, but that's true. Right? There are these things called lambda expressions, which we don't cover in this course. Yeah, I'm just going to leave it at that. We don't cover that in this course. And there are things called modules that we also don't cover in this course. Right? You click on that link, that takes you to Oracle's tutorial, the Java tutorials that describe the structure of a typical Java program for you. Okay? But there is a lot more to the language than we can possibly cover in one course. Okay, packages. So packages is one of the mechanisms that Java uses for modularity. Right? So remember modularity, we take a program, we split it up into separate pieces. Right? One of your pieces are classes. Right? But I can group classes, or I can group related classes together in what's called a package. Right? So packages are used to organize Java classes into what are called namespaces. Right? Now, I don't really care if you know what a namespace is. Right? This is the technical definition for a package. So a namespace is just a container for names. Right? So in other words, every package has a name. Right? That package is allowed to contain other names. And that's all that it means. Right? So every package has a name. You can put other packages inside of a package. That's essentially how this works. Okay, so packages are used to organize related classes and these things called interfaces. Right? So for example, all of the Java standard library, that's not quite true. All of the fundamental Java standard library classes, they all go into a package called Java. Right? So there's this one giant package called Java. It's got a whole bunch of classes and other packages. Right? Now, a package is allowed to contain other packages, right? So on your computer, you can have a folder, right? That folder can have other folders. That's exactly the same thing with packages, right? So your package can contain sub-packages, right? So the Java package contains a package called lang, right? That's where all of the very fundamental Java classes go, right? It has a package called util. That's where all of the useful Java classes go. And then it has a package called IO. So that deals with input and output, right? So once you start putting packages inside of packages, you need to decide how am I going to name these packages, right? So there's something called the fully qualified name of a package. So the fully qualified name of the package is just all of the packages stuck together, right? So you take the parent packages, right? So for lang, its parent package is Java. So you write Java. Then you write a period, and then you write the name of the package. So lang. Right? So java.lang, that's the fully qualified package name of lang. Right? Java.util, that's the fully qualified package name of util. And java.io, that's the fully qualified package name of io. Right? The name of the individual package, or the unqualified package name, is just the name of the package. Right? So you got a package called lang. Its fully qualified name is java.lang. So lang contains all of the classes that the language designers decided were absolutely fundamental to the language. So there's a class called big O object. There's a class called big S string. There's a class called big M math. And there's several other classes. Right? So once you have an object, or a class, sorry, inside of a package, then you have what's called the fully qualified name of the class. Right? Not surprisingly, that's just the fully qualified name of the package, followed by the class name. Right? So what's the fully qualified class name of object? Well, it's java.lang.object. Right? What's the fully qualified name of string? Well, it's just java.lang.string. Right? Why did they do this? It's because there has to be some mechanism that ensures Names are unique, right? So names are unique. So imagine that they didn't do this, right? There's this class called string that represents Java strings, right? There's nothing from stopping another programmer from creating another class called string, right? So now you have two classes called string. And now the question is how does the compiler and the virtual machine figure out which class do you want to use, right? So without the package mechanism or without some other mechanism to distinguish between the same things with the same name, you'd be stuck, right? You'd be forced to give every type that you create a different unique name, right? Now the problem with that is you have no idea what some other programmer is going to name their class, right? And so there might be, at some point, you're going to run into the problem where you want to use someone else's code. They've named their classes the same name as some of yours, and now you've got a problem. You can't use them in the same program, right? However, if you've got packages, then you can at least, you can attempt, right? You can attempt to create unique names by using the fully qualified package name, right? So for example, suppose you create your own string class because you decide that the Java string class doesn't quite do what you need it to do, right? You can make your own package. I'm going to call it your. Then you can put your string class in that package, right? And now when I want to use that class, I can write your.string everywhere, right? I can use the fully qualified package name, right? When I want to use the Java version of string, I can just write string. So both of these string classes can coexist in the same program at the same time, right? And that's nice, right? If you ever take CISC124, you're going to run into a language called C. And in C, there is no package mechanism, which greatly complicates how you write your programs, because everybody who provides some sort of C library has to make sure that they name their classes uniquely, their types uniquely, right? And there's no mechanism to help you if that doesn't happen, right? Okay. Now, there's still a problem. So there's no guarantee that you're naming your packages uniquely, right? And so there's what's called a package naming convention, right? So packages should be organized using your domain name in reverse. Now, if you don't have a domain name, you're kind of stuck, but you can always apply for one, right? So domain names are supposed to be unique. There is a central registrar of domain names, right? So the way you're supposed to name your class, your packages, is to take your domain name and reverse everything, right? So for computing science at Queen's University, our domain name is cs.queensu.ca, right? If the computing science department were to release a bunch of Java classes, right, then they're supposed to release them in the package ca.queensu.cs, right? Just reverse the domain name. Right. So if you look at the source code for the course, you'll see that all of the packages for CISC124 are in ca.queensu.cs something, right? And speaking of the source code for the course, if you haven't downloaded it from GitHub, there is now a link under content, under course reading and resources. You can't see a lot of these. A lot of these are hidden to you. So right there, you can grab all of the source code that's used in the course from OnQ, right? You can also get it from GitHub if you want, but this is probably easier, right? Just download that zip file and suck it into Eclipse like you suck in, like you import any of the assignments, right? That'll give you all the source code. There's a lot of it, right? So over here, let me just get rid of these for a second. I should really get rid of that one because that's, oh no, wait, okay. Over here, whoop, right? So that's the project you'll import when you have the course. If you import that package in, if you import that project into Eclipse, that's all the source code, right? So those are all the packages containing the source code for the course, right? The Java doc is also here. So under the doc folder, if you click on index, that takes you to the documentation for all of the classes, right? So every class and interface that's in this course also has documentation for it. All right. Okay. So now you know what a package is. You know why they exist, right? Now you'll notice on the assignments I'm just naming them A1 and A2 and A3. That's because I'm too lazy to type in CA, Queens U, CS, CISC124, assignment 1 every time, right? Saves you a lot of typing too. So everything's in a simple package. Okay, classes. So a class is just a type, right? I guess more precisely, it's an implementation of a type, right? If you decide that I need some other type, you just make a class, right? The class is usually used to make objects, right? So normally the class is a blueprint that's used to make instances of the class, right? Now, why do we do this, right? So why do we bother making a class and then create objects, right? So every object owns its own copy of all of the non-static fields that are defined in a class, right? So in other words, you've got some variables that are in a class. If those variables are not static, then every object that you make using that class gets its own copy of that variable, right? And so this allows objects to have their own state, right? So in Java, the state of an object is just the set of current values for all of its non-static fields, right? So every object can have some variables that belong to the object, right? The set of values of those variables, that's the state of that object. Okay, so we're going to look at this class called point2. Point2 is a class that can represent a two-dimensional point, right? Something with an x and a y coordinate. So here's an example. The point2 class is, you have access to that. It's in, I think for the purposes of our lecture right now, it's in here. So notes, basics, geometry. And there's point2. Okay, so I've got 3 points, P, Q, and R. Right? So I actually want 3 separate points in this little program, right? So I want a point whose coordinates are 1, 2. I want a second point whose coordinates are minus 3, 8. And I want a third point whose coordinates are 5 and 13. Right? So I actually want 3 separate points. Maybe I'm trying to draw a triangle or something like that. Right? So if you have objects, then you can actually have 3 separate objects that have the coordinates 1, 2, minus 3 and 8, and 5 and 13. Right? And so in this example here, when you write new point2, right, a point2 object appears. A point2 object appears in memory. Right? When you call the constructor point12, that fills in the coordinates of that object so that its coordinates are 1, 2. Right? When I write new point2 minus 3, 8, right, that creates a point2 object, right, somewhere else in memory, right? Objects can't overlap in memory, right? It has the coordinates minus 3 and 8, right? And my third point here, right, somewhere else in memory, right, has the coordinates 5 and 13, right? So you've actually got 3 distinct points in this example, right? Now remember, P, Q, and R, those store references to the points, right? So P stores the memory address 600, right? Q stores the memory address 700, and R stores the memory address 800. All right, now what do we mean by a class is used as a blueprint to make instances of the class or to make objects, right? So if you look at the point2 class, right, the first time you use a class in a Java program, that class gets loaded into memory, right? When you look at the point2 class, you'll see that it has a variable called x, and it has a variable called y, right? So whenever you make an object, what new does is it takes this class and copies it, right? So new point212, grab that class and plunk down a copy of it up here. Right? The constructor now fills in the values 1 and 2, so it fills in the values x and y as 1 and 2 in that object. Right? When you write new point2 minus 3, 8, grab that class, plunk down a copy here, fill in the values minus 3 and 8, right? And so on and so on. Right? So that's what it means when we say that the class is used as a template or as a blueprint to create objects. Right? You literally make a copy of the class, and that becomes one of your objects. Right? Okay, so how do you implement a class? Well, it depends on what you want to do. We're going to look at implementing what are called value type classes. So a value type class is something that represents a value, right? So for example, a name, a date, a month, a year, color, a point, right, or a vector, right? These are all examples of what are called value type classes. Right? Now when you make one of these classes, you have to decide, okay, so I want objects of these classes to represent some kind of value, right? What variables does each object need, right, in order to represent this thing that I'm trying to implement? Right? So the variables that you define that represent the state of an object, these are called fields, right, in Java. So that's the Java term for this. The object-oriented programming term is attribute, right, which you'll often see. I guess you often see that in Python programs. But there's many, many other object-oriented programming languages. The general term is attribute. Java calls them fields. Okay, so I want to implement a two-dimensional point, right? So a point having an x and a y coordinate, right? I have to decide how am I going to represent the x and y coordinates. Right? So the obvious answer is I'm going to make a variable called x and I'm going to make a variable called y, right? If I want real valued points, then I'm going to have probably use double, right, for the type of x and y. Right? That's not the only way to do it, right? You could decide, well, I can just make an array of size 2, right? So I can make an array called, I don't know, A or chord or something like that, right? The first element in the array would be the x coordinate. The second element would be the y coordinate, right? So that'd be another way to do it. And you can come up with lots of other ways to do it as well, right? If you wanted an integer point, you could pick two fields, x and y, and their type might be int. Right? We're going to use x and y, and they're going to be double. Okay? So if you're looking for the source code for this, it's in this package here. Right? So in Eclipse, just find that package. You'll find the point2 class. Right? Here I've got public class point2. Right? So that's how you declare your class. Right? You decide on a name. You need the keyword class to indicate that it's a class. Public means that anybody else can use this class. So that's probably what I want in this case. Right? Now, I need to decide, what does every point2 object need? Well, it needs an x and a y coordinate. Right? So I'm going to have two separate variables here. Right? Their type is double. Now, these are marked as private in this example. Okay? So this is the first time you've seen this access modifier called private. So when a variable or a field has an access modifier, right? The access modifier determines which classes can see this field, right? A private field means that only the point2 class can see this field, right? So only point2 and point2 objects can see the fields x and y, right? Any other class, right, does not have direct access to x and y, right? So if you give another class the point2 object p, or a reference to a point2 object p, right, that other class is not allowed to write p.x equals something or p.y equals something, right? They cannot access the fields directly. Right? So private, only the class and other point2 objects can access x and y by name. Right? Okay, so point2 is what's called a top-level class because it's not defined inside of another class. Right? So notice point2, there is no class around it. So point2 is a top-level class. So a top-level class can either have no access modifier, right, or it can have a public access modifier. Right? So in other words, that access modifier there is either public or it's not there. Right? So if it's not there, then it's what's called package private access. What that means is the class is visible only inside of its own package. Right? So in other words, if I was to strike public from here, right, then point2 is only visible inside that geometry package. Right? Only classes inside geometry can actually use point2. Right? For the current time, all of our classes are public. Right? There is a reason for making package private classes. We don't know what that reason is yet. Right? So for now, everything's public. Right? All of our classes are public. Also for now, I think all of our fields will be private. Right? So keep that in mind. Fields can actually have one of 4 different access modifiers. right? So you can have a private field. So the field is only visible inside the class that it's in, right? You can have no access modifier. So that's called package private, right? That means the field is it's the same as private, but other classes in the same package can also see those fields, right? So, if we got rid of private here and private here, then any class inside the geometry package can access x and y of point 2 by name, right? So if you give it a point p, those classes can write p.x and p.y. Protected. So protected access means the same thing as package private, right? So the field is visible inside the class. The field is visible to classes inside the same package. And now the field is also visible to what are called subclasses of that class. So we're going to look at this, I guess, starting around week 8 or 9. Right? So don't worry about protected for now. And finally, public. A public field is visible to all classes everywhere. Right? So if you have a field that's public, any class can see that field. Right? Furthermore, any class can modify the value of that field, which might not be what you want. Right? Okay, so the rule of thumb that you should use for now, your field should always be private unless that field represents a constant value that is meaningful to the class. Right? So, for example, in the class math, there's a field called big pi, that represents the mathematical value of pi. Right? It makes sense to make that public because other people are going to want to look at that. Other people are going to want access to that value. Right? If you make it constant, that value can never change. Right? If you make it final, that value can never change once it has a value. So you don't have to worry about other people changing that field. Right? So for now, when you create a field in your class, make sure that it's private. Right? And we'll look at why you would make a protected field later on in the course. Okay. So we've started to implement point 2. So let's look at another example of starting to implement a class. So I want to implement a class that represents a counter. Right? So I want something that starts counting at 0, and it can count up in increments of 1. Right? So what fields do you, oh wait, that's not right. What fields do you need to represent a counter? Okay, so what fields do you need to implement to represent a counter? Well, I need something that's going to count up in increments of 1. Right? So what do I need? I need a field that represents the count. Right? That seems pretty easy. Right? So in the counter package, there's a class called counter. Right? What do I need to represent the count? Well, if it's counting by 1 every time, then it seems like an int value is appropriate. Right? So I'm going to create a field called value, and that just represents the current value of the counter. Right? Notice that it's private, so nobody else can access that field. Right? Only the class counter can access that field value. Okay, so how about another example? I want to implement a stopwatch now. Right? So this is a stopwatch that someone can use. They can press the start button, they can press the stop button. Right? When you press the stop button, it tells you how much time has elapsed since you pressed start. Right? Just like a physical stopwatch. Okay, so what would you... you can see that I copied and pasted a lot of slides here. So what do you need to represent a stopwatch? Okay, so what do you need to implement a stopwatch? And the answer is you probably don't know, right? This one's a little harder. So you just start thinking of what you can. You just start thinking of ideas of how you could actually implement this stopwatch, right? So someone presses start, someone presses stop. So you could say, well, I need the time at which they pressed the start button, right? And then I need the time at which they pressed the stop button, and then maybe I can subtract the two to figure out how much time has elapsed, right? And that actually turns out that makes sense, right? So how do I get the time? And it turns out there's lots of ways you can get the time, right? So number one, you can actually get the time as though it were a time on a clock, right? So there is a way to do that. I'm going to do something different. So I'm going to use this method called system.nanotime. Right? And so if you go and look at the documentation for the system class, right, you'll find that there's this method called nanotime. Right? When you look at what it tells you, right, so nanotime, the document says it returns the current value of the running Java virtual machine's high resolution time source in nanoseconds. Right? So times 10 to the minus 9 seconds, which is probably overkill for this particular example, but that's fine. Right? Okay, so the value returned represents the number of nanoseconds since some fixed but arbitrary origin time. Right? So all it's telling you is that you get back some long value. Right? You get back some long value. It's some number. You don't actually know what that number means. It's the number of nanoseconds since some time. Right? Which is, turns out that's going to be fine for our purposes. Right? So if I call nanotime when you press the start button, and then when you call nanotime when you press the stop button, the elapsed time is just the stop time minus the start time. Right? Okay, so here's our stopwatch class. Right? I need some field to represent the start time. Right? So that's the time when the person presses the start button. Right? I need some field to represent the stop time. So that's the time when the user presses the stop button. Right? And now you might say, well, look, if you look at a real stopwatch, it actually tells you the time, right, that's elapsed, even if you don't press the stop button. Right? So it tells you how much time has elapsed since you pressed start. Right? So if you want to implement that feature, so if I want someone to be able to get the amount of elapsed time while the watch is running, right, I need to know, is the watch running or not? Right? So how can you represent whether or not the watch is running? Well, I can use a Boolean field for that. Right? True if it's running, false if it's not. Right? And so there's the start of our stopwatch class that we'll finish in the next lecture. Any questions? Super. Do you need an extension for the assignment? Yes? Okay. You have how long of an extension do you want? So you have to keep in mind that the other assignment is ready to come out. So there is another one coming out. I do know you have a lot of midterms this week. So it's probably not a good idea to make it due after reading week, is what I'm saying. So when do you want it due? Wednesday? Wednesday? Is that good? I could do Friday, but it's going to squeeze the amount of time you have for the next assignment. Wednesday or Friday? Wednesday it is. I will change the due date. Hey, no problem.
Sorry?
Question?
Yeah, I got a question, two questions about the assignment actually.
Sure.
So first, I noticed that the